Hello guys, welcome back to mathematics. Today we are going to learn the case of factorization for polynomials with the greatest common factor. So let's start with a small example with just two numbers, for now without any variables. So you are going to see how it works. So we know that these numbers could be expressed as a multiplication of prime factors. For example, the 12 could be expressed as 2 times 2 times 3. And the 18, it could be expressed as 2 times 3 times 3. So what they have in common is the 2 and the 3, right? So we would say that the greatest common factor between them, it would be the 6. So using the distributive property of the multiplication and addition, we could express this as 6 times the number to multiply 6 to get 12 is 2, plus the number to get 18, which is 3. So notice that we apply the distributive, we are going to go back to what we had before. 6 times 2 is 12 and 6 times 3 is 18. But we have applied a factorization because we convert this into factors. Remember, factors is associated to a multiplication. So this would be the first factor and the second factor. So the idea when we have polynomials is the same. Just that, as you know, in the polynomials we have also variables. So in this case, we would still use the greatest common factor for the numbers, but we are also going to find the greatest common factors between variables. So when we have a repeated variable, but with different exponents, we are going to choose that letter with the smallest one possible. In this case, is the one that, remember, is not written there, but it's there. So we would leave it just like that, 6x. And we were able to do this just because every term in the expression has the x. And then in the parentheses we would have something similar. It's just that now it's not enough with the 2 to multiply to get the 12x to the square. We are also going to need another x here. So x times x is going to be the x squared that we had at the beginning. So 6 times 2 is 12 and x times x is x squared. For the other term, we still put the 3 because 3 times 6 is 18. And in this case, we don't need the x because the 6 already have it. So 6x times 3 is already 18x. So we have factored a binomial already. This is already a factorization. We would call 6x the common factor, and then this parenthesis would be the second factor. Let's see this other example that we have more than one variable. So we still have 12 and 18, so it's again 6 the greatest common factor between the numbers. Now let's see the variables. We have x to the cube and x to the square. Again, we choose the smallest one, so it would be x to the square. And then they both have y, so we should also include it. And the smallest power that we have here is the 5, so we are going to have y to the 5 power. This is the common factor, so we start with the parentheses to find expressions that we are going to multiply to get the initial expression. So let's see. Again 2, because 6 times 2 is 12. And then x squared, we would have to multiply by another x to get x to the cube. And we already have y to the 5, so we don't need to multiply y in this term. Minus, remember we need to keep the signs. Minus, and then we would put 3, since 3 times 6 is 18. We already have the x squared, so we don't need to include x anymore. And y is given to the 7th power. And here we have it to the 5th, so we still need 2 more to go. Remember when you factor to check that if you actually do the multiplication, you get the initial values. That's going to help you to avoid mistakes. This method of the greatest common factor could be used in polynomials that have any amount of terms. So this one, for example, has 3 terms. This is a trinomial. So we can also apply it. Let's see. 3 is the smallest number. That's a prime number. So let's check if maybe the other ones are multiples of 3. The 9 is a multiple and the 21 too. So yes, 3 should be the greatest common factor between the numbers. Let's check the letters. X is present in all of them. And the smallest exponent is the 2, so we would put the 2 here. And let's see what happens with y. It is present in all of them, so we still put it. And the smallest exponent is this one, is 1. So we leave it as 1. And z, notice that is just in the first term. So we cannot include it. It's not common for all of them. And then we open parentheses. Remember, we always want to find something to multiply, so we get the first one. 3 times 3 is 9, then we should put a 3. We need x squared, and we have x squared, so we don't need to multiply it again. Y is to the 5th power, and here is just to the 1 power. So we should put 4 in the exponent. And z, we don't have it, so we also include it. Let's check. 3 times 3 is 9. X squared is alone, so x squared. Y to the 1 plus 4 is 5. Excellent. And z. Good, the first one is correct. Minus the next one. The 3 is already there, so we don't have to multiply by a number. We just need to worry about variables. So we have x to the square, and we want x to the 4. So we need to include x to the square. X squared times x squared is x to the 4th power. Good. And the y is to the 1 power, and we need the square, so we just need to multiply another one. Plus 3 times 7 is 21. X squared times x is x to the cube, and y is already there, so we just close it. Let's see some other examples. In this one, notice that 70 is the double of 35. So 35 should be the greatest common factor. 35, m to the square, that would be the smallest one. And n is just present here, not here, so we shouldn't include it. 35 times 1 is 35. M to the square times 1 is m to the square. And n to the cube is the only thing that we need. So n to the 3rd power. Minus 35 times 2 is 70. And m squared times m is m to the 3rd power. So this is already the answer. And finally, let's check this one. Notice that it has 4 terms, but it has no limit, guys. You can use this method to factor even if they have 10 terms. It's just that sometimes they don't have anything in common, so you wouldn't be able to factor it. But there's no limit about what you can factor in this case. Okay, let's see. Well, they all seem to be multiples of 10, actually multiples of 50, and 50 is the smallest one. So that should be the greatest common factor. 50. A, let's check if it's present in all of them. Yes, it is, so we include it. The smallest one is this one that doesn't have any power, so just A. B is present in all of them, and the smallest one again is 1. And C, it is present in all of them, and the smallest one is this one, the first one. So we start with parentheses. 50 times 2 is 100. A times A is A to the square. B times B squared is B to the cube. And C times 1, so we don't put anything else. Minus 3. 3 times 50 is 150. A times 1 is A. B times B is B squared, and C times C is C squared. Plus 50 times 1, so we don't need to put it. A times 1, again. B times B squared is B to the cube, and C times C squared is C to the cube. Minus 200, so 50 times 4 is 200. A times 1 is A, B times 1 is B, and C times C is C squared. So the result of the factorization is this one. Okay guys, sometimes what they have in common is not just a number and some variables, but it could be a parenthesis. Notice that we could take this as a term and this as the second term. And they have in common a parenthesis. This parenthesis is in both terms. So we could also call that parenthesis a common factor. So we could factor this polynomial using that parenthesis, x plus 1. They have it in common. So we would have to multiply by a to get this first term, a, and multiply by plus b to get this second term. So notice how if we multiply x plus 1 times a, we get this first term. And if we multiply x plus 1 times b, then we would get the second term. So this is equivalent. But initially we had an addition, and now what we have is a multiplication. It's a factorization. Let's see what happens in this one. This is the addition that separates two terms, this one and this one. And what they have in common in this case is the m plus n. You see? So that means that we could write m minus n because it's present in both. And in the parentheses, we actually have another parenthesis here, x squared plus 2. You could write it in parentheses or not. There's actually no need to it, so we could just leave it without. And then plus 2. And we close. Notice that in this case, we actually got two like terms in the parentheses. So we could also operate them. So we would have m minus n times x squared plus 4. And that would be equivalent at what we had before. So we changed an addition and we converted it into a multiplication. We did a factorization. And finally, let's check this one. This seems like we have a plus 1 here and a plus 1 here. But what should we do with this one? It doesn't have a plus 2. It has minus a minus 2. Okay, so that means we need a little transformation before. We could write this as x times a plus 2 minus, and I can open parentheses here, so the minus is going to affect everything what I put inside. Since they are both negative, that means I can factor the parentheses and write a plus 2 inside parentheses. Notice how if I apply the distributive, this is just going to be minus a minus 2, which is exactly what I had before. So we could leave it like that, so the parenthesis repeats. Plus 3 times a plus 2. Now we have the parentheses for all the terms. And then we can factor. A plus 2 is a factor of x. Here doesn't have anything, so it should be a 1. Notice it's the same thing to write a 1 here. Minus 1 and then plus 3. Similar to the last one, we could also add alike terms here. So a plus 2 times x plus 2, because 3 minus 1 is 2. And that would be the factorization. Okay guys, it's your time to practice. So please try to find the greatest common factor and factor these polynomials. Okay, I'll give you the answers in a second, so pause the video, solve them, and then come back to check your answers. Okay, let's see. So for this one, the answer is 5m is factor of 6m plus 1 minus 3m to the cube. Of course, you can always organize it as 5m factor of minus 3m cubed plus 6m plus 1. This second one is 17a is a factor of 2x squared plus 3ay minus 4y to the square. This one we could consider it like organized already. And finally, this one, it would be 1 minus x is a factor of 1 plus 2a. And that's it, guys. If it was useful, please let a like in the video. Don't forget to subscribe. Put your own lessons with me if you want. And let me any questions or any problem or any other topic that you want me to explain in the comments box. Bye bye, guys. See you next time.